Hi friends, welcome back to C Level Physics. My name is Srinivas. In this lecture, I would like to explain slope of graph. Okay. Suppose if any quantity y changes with x, then y is said to be function of x. Y is said to be function of x. Suppose I am taking a variation of y with respect to x as shown. See, this is what x and y axis, x and y axis as shown. This is what x-axis, this is what y-axis, right? A quantity x is taken along x-axis and y is taken along y-axis as shown. Now variation of y with respect to x is as shown like that. See, this is the variation of y with respect to x, right? Right. Now I take 2 points on the curve A and B, somewhere here A, somewhere here B. Am I right? So these are what 2 points selected on the curve as shown. Now accordingly, what are the values of quantities x and y? Suppose at point A, this is what x1. At the same point, this is what y1. Right? Now, as far as point B is concerned, what is the value of x? Here, this is what x2. This is what y2. Okay, so x1, x2, y1, y2 are the values of quantities x and y at points A and B respectively. Okay, right. Now, what is this point origin? This is what origin. Now, what is this measurement from O to this point means x2, from here to there x2, from here to there x1. Now, what is this interval or separation here means that is delta x. This is what delta x. Here it is delta x. Right, delta x. Similarly, 0 to this point, what is this measurement y2? From here to there, y1. Now, what is the measurement from here to there? That is y2 minus y1, that is equal to delta y. So, this measurement is delta y. Okay, so here it is delta x, here it is delta y. So, it is point A, here it is point B. Right, now here, as y changes with respect to x, y can be written as y equal to function of x. Y can be written as function of x, right? Including changes y plus delta y can be written as f of x plus delta x also. Y plus delta y equal f of x plus delta x, right? Suppose here as point B approaches to A, what happens? This line come closer to this line. Similarly, this line come closer to this line. Therefore, delta x becomes dx, delta y becomes dy. Why? Because here A and B are broadly selected on the curve. See, there is some gap between A and B, right? So that we have large separations here. Here it is delta x, here it is delta y. Delta x, delta y are large values. If you want to get small values, then B is to be shifted towards A. Means if B approaches to A on the curve, then this line come closer to this line. Am I right? This line come closer to this line. So this line come closer to this line. Therefore, delta y becomes dy, delta x becomes dx. Right? What happens here if Q approaches to P? If Q approaches to P, what happens? Implies delta y becomes to delta y approaches to dy and delta x approaches to dx. So in general, deltas are large values, d's are small values, right? Then what happens here? If I take one tangent at point P, suppose at point P I am taking one tangent here, I am taking tangent at point P. This is what tangent, right? Drawn at point P. Now, as B approaches to A, almost this curve becomes straight also. This curve becomes straight. So, you can get a triangle like that. So, this is what A, this is what B. In fact, this is somewhat curved shape. So, as B approaches to A, the curve becomes straight here. curve becomes straight line. So if I take some angle here theta, here it is theta, some angle theta, then here also theta. Now what is this side? Delta y. Delta y becomes dy. What is this value? Delta x becomes dx. So with respect to theta here, opposite side is delta y. Then what happens as b approaches to a, delta y becomes dy, delta x becomes dx. So if I take tan theta here, opposite side by adjacent side, that is delta y by delta x becomes reduced to dy by dx. Right? Here what is theta? Theta means slope angle. Theta means what? Here it is. Theta means slope angle. Theta, slope angle at P, point P. So theta means slope angle drawn at point P. Right? Now, if I take tan theta here in this triangle, if you take tan theta becomes equal to tan theta becomes equal to tan theta becomes equal to opposite side by adjacent side, that is dy by dx. Opposite side by adjacent side. Alright. So here tan theta is equal to dy by dx is known as slope of that graph drawn at point P. Right. So this is what? Slope of y, which is function of x. Slope of function y equal to f of x at P, at point P. So what is tan theta? Tan theta equal to opposite side by adjacent side, that is delta y by delta x in fact, but that is reduced to dy and dx. So tan theta equal to dy by dx, which is known as slope of function y equal to f of x at P. Right? So here tan theta itself slope of function. Tan theta means tangent of angle made by the tangent drawn to the curve at point A. At point A. Here it is A. Point A. It is point A. Alright? Here theta always is to be taken with the positive x-axis. Suppose if I extend this tangent up to here, this is also theta 1. This is also theta 1. So in fact, this is the curve taken here. This is the curve taken in fact. But I took one tangent drawn at A to the curve. Right? That is extended up to here. So which makes an angle theta. So here also making an angle theta with an axis parallel to x-axis. In fact, this is the x-axis. But here it is. What is this axis? One more axis parallel to x-axis. So here the angle taken with this axis is equal to angle taken with x-axis. Why? Because this axis is parallel to x-axis. Okay, right? Right. Here, what is the important point here? Theta means slope of angle drawn at point A. Point A. Right? Now, one condition is there that in assigning angle, theta always must be taken with the positive x-axis only. What is that point? Theta must be taken with the positive x-axis only. Positive x-axis only. Right? So this is what slope. So what is the inference here? If any point y is taken along y-axis and any point x is taken along x-axis, if y changes with respect to x, then y can be written as function of x. Then y dy by dx is known as tan theta and is known as slope of that function y equal to f of x. Alright. So tan theta equal to dy by dx is the slope of function y equal to f of x. Y equal to f of x. Right? Now, if I take any physical quantity, suppose displacement versus time. Time is taken along x-axis, displacement is taken along y-axis. Then what is the What about slope? Right? What does it represent? Let us see. Similarly, if I take time along x-axis and velocity along y-axis, what is the slope of that curve? What is the slope of variation of that curve? Similarly, if I take time along x-axis and acceleration along y-axis, what about its slope? Let us see one by one. Of course, here tan theta equal dy by dx is known as slope of function. In other words, dy by dx also known as differentiation of y with respect to x. So, tan theta equal to dy by dx is known as slope, also known as differentiation of y with respect to x. Differentiation of y with respect to x. Okay. So here it is A, point A from the graph. So here also point A from the graph. Okay. Now let us see, by replacing x and y with the time and position. Position means the displacement. Suppose position or displacement is taken along y-axis and time is taken along x-axis. Let us see, what about slope of that graph? First one, position versus time. For example, see here, this is what time, this is what displacement, otherwise position x. Either displacement or x, position x, taken along y-axis and time is taken along x-axis. Am I right? Now, suppose this is a variation of displacement with respect to time as an example, a straight line as an example. Suppose here I took 2 points at A and B on the curve. Alright? Accordingly, what are the values here? This is T1. This is what? Either S1 or X1. Either S1 or X1. Either S1 or otherwise X1. Similarly, at point B, what are the values for time and displacement? Here it is T2. Accordingly, here it is X2 or S2. Either X1 or S1, either X2 or S2. Right? Now, if I take one tangent at point A, see, the variation of x versus t is a straight line, linearly changes in this example. Right? The position of particle changes with the time linearly, means straight line. If I take one tangent drawn at point A, then that becomes what happens, coincides with the line itself. Now, what is the angle made by this tangent with the x-axis? See, this is what x-axis. If I take parallel axis to x somewhere here, this is what theta. Right? This is what theta. Now, what is this interval? Delta t, otherwise dt. Delta t, otherwise dt. What is this interval? That is delta x, otherwise dx. Now slope equal to, what is the slope here? Slope equal to tan theta. Tan theta equal, see this triangle, tan theta. Opposite side by adjacent side, that is dx by dt. Dx by dt. Otherwise ds by dt also. Ds by dt. If I take S1, S2, then it becomes ds also. So therefore, slope equal tan theta equal dx by dt or ds by dt. Now what is the rate of change of position with respect to time? Means velocity. Similarly, what is the rate of change of displacement with respect to time? Velocity. So slope equal to velocity. In case of position versus time graph. What is this graph? Position versus time graph. Otherwise, displacement versus time graph. Similarly, next example. Time is taken along x-axis and velocity is taken along y-axis. See, this is what velocity. Here it is time. Right? Velocity versus time. So this is what number 1. This is what number 2. Velocity versus time. Suppose this is the variation of velocity with respect to time, as in the previous case. Straight line means velocity varies linearly with the time, as an example. Then take 2 points on the line, somewhere here A, somewhere here B. Now take the values relevantly, that is, this is what x1, t1, this is what v1. Similarly, at this point t2, here it is v2, here it is v2. Now if I take one more axis parallel to time axis somewhere here at point T, at point A, so this axis becomes parallel to time axis or x axis. Alright. Now this is what delta t. This is what delta t or dt. This interval is what v2 minus v1, that is dv. Delta v, otherwise dv. Now if I take one tangent drawn at point A, this is what tangent. See, white chalk, that is tangent drawn at point A to the curve. Now the tangent coincides with the line itself. Right? Why? Because already variation of y with respect to time is linear, means straight line. So in case of straight line, slope is constant at any point on the line. Am I right? Not only at this point, at any point on the line is same. Slope is constant. Slope is constant. Right? Now if I take angle, slope angle somewhere here at point A, slope angle theta, that is slope equal to tan theta. That is variation of y coordinate divided by variation of x coordinate. That is dy by dx. See, if y is taken along y axis and x is taken along x axis, now dy by dx equal to slope. Similarly, on y axis velocity is there, on x axis time is there. Now what is dy by dx here? Dv by dt. So slope equal to tan theta equal to dv by dt. dv by dt. What is dv by dt? d by dt of v. d by dt means rate of change of what? V. So rate of change of velocity means instantaneous acceleration. Usually it is known as acceleration. So what does it represent? The slope of velocity versus time means acceleration. Acceleration. Right? So the slope of velocity versus time graph is instantaneous acceleration or simply acceleration. One more variation, that is between acceleration versus time. Suppose acceleration is taken along third case, that is number 3. Third point, that is acceleration versus time. Right? Acceleration versus time. Suppose the variation of acceleration with respect to time is like that. At point A, what is the value of acceleration? A1. At point B, what is the acceleration? A2. At point A, what is the time? Instant t1. At point B, what is the instant t2? So what is the interval here? From 0 to this position t2, here it is t1. From here to there t1, here to there t2. Now what is this time interval? Means t2 minus t1, that is dt or delta. So from here to there, what is the value of acceleration? A2. From here to there, A1. From here to there, what is the value? Means A2 minus A1. You will get the A2 minus A1. That is delta A or dA. Delta A or dA. Right? Now here slope is, what is slope? Slope equal to tan theta. That is tan theta means change in y coordinate by change in x coordinate. That is dA by dt. Tan theta. See this right angle triangle. If I take one tangent here at point A to the curve. At point A, I am taking one tangent to the curve at this point. Now that coincides with the line itself. Why? Because the line is straight line. Therefore, tan theta equal to opposite side by adjacent side. That is dA by dt. dA by dt. dA by dt means the rate of change of acceleration with respect to time. That is to be pronounced as the rate of change of acceleration with respect to time, means jerk. This is known as jerk. Okay. What is jerk? The rate of, if acceleration is not constant and changes with respect to time, then the rate at which acceleration changes is to be known as jerk. Right? What are the units? Units means here dA by dA means meter per second square by time is there. So meter per second by second, that is meter per second square. Meter per second square by second, that is meter per second cube. Meter per second cube. So what is the reference here? If any quantity changes with if any quantity y changes with respect to another quantity x, if x is taken along x-axis and y is taken along y-axis, then dy by dx is known as slope of graph. Usually that is tan of theta, where theta is slope angle. Similarly, the slope of displacement versus time graph is velocity. The slope of velocity versus time graph is acceleration. Similarly, the slope of acceleration versus time is jerk. Right? Okay. Now, let us see the nature of slope in next diagrams. Nature means the slope of curve may be positive or negative or zero. Let us see. Maybe positive or negative or zero. First case 1. In case 1, first example is what? Y. The point y is taken along y-axis. The point x is taken along x-axis. Means the variation of y versus x. Suppose you are given like that variation. You are given like that. See this variation, right? This is the variation of y with respect to x. See, somewhat concave upwards. Concave upwards. Suppose if I take 2 points on the curve, one is somewhere here at point A, one more is somewhere here at point B, Now take tangents drawn at point A and point B. Suppose at point A I am taking tangent like that. See, this is what tangent drawn at point A to the curve. Now what is the angle here? Suppose if I take one axis parallel to x-axis, that is, this is what x-axis parallel to an axis parallel to x-axis, right? Now what is the angle made by this tangent drawn at point A with parallel to x-axis means theta. Of course, here also theta 1. Why? Because these two are same angles, right? Similarly, if I take one angle somewhere here, if I take one tangent somewhere here like that, drawn at point B, this would be the tangent. Right? Tangent. Now, parallel to x-axis, I am taking one axis parallel. This is the point at which tangent is drawn. So this is what an axis parallel to x-axis. So taking angle with this axis is equal to taking angle with x-axis. Why? Because these two are parallel to each other. So what about the angle here? Here it is theta 1. Here it is theta 2. Here it is theta 1. Here it is theta 2. Right? Now here what is the value of x here? That is x1. Here it is value of x2. That is x2. So at point A, what is the value of x? X1. At point B, what is the value of x? X2. Right? Here it is y1. Here it is y2. Am I right? Now see here, these two angles are obtuse or acute angles. Why? Because see, I am saying we can say that theta less than 90. For theta less than 90, tan of acute angle becomes positive. Means slope is positive. Theta. What about theta here? Theta here acute angle means less than 90. Right? What about that is tan of acute angle? Tan of theta, that is less than 90 degrees. What about slope? Slope is positive. Right? Slope is positive. Now, as x increases, see from A to B, if you go from A to B, x increases from x1 to x2. Of course, y also increases from y1 to y2. See, as x increases, what about theta? Will it decrease or increase? See, initially at x1, what is theta here shoots down. At x2, what about theta here shoots up? See here once again, this is the slope, that is the slope. So tangent shoots up here, here shoots down, here shoots up, means theta increases. Theta increases. So as x increases from x1 to x2, implies what happens? Theta increases. Theta increases means tan theta also increases. Right? Theta increases, tan theta also increases. Tan theta means what? Slope. That is slope. Tan theta means slope. That is equal to dy by dx. Dy by dx increases. Slope increases. Right? Slope increases. Right? So this kind of graph, say concave upwards, slope increases. Moreover, is it positive or negative? That is positive slope. Positive slope. Why? Because theta is less than 90 here. If you take somewhere here or here or here at any point on the curve, right? Theta less than 90 only. Up to here, less than 90. Therefore, theta is positive. Now coming to one more model, that is second example. Second example. What is that example here? Second example, that is second one. Variation of y versus x is as shown. For example, as shown. This is what x quantity x, and is quantity y. So quantity x is taken along x-axis, quantity y is taken along y-axis. Now variation is like that this time. Variation is like that. Variation is like that. Now see, if I take tangent at 2 points on the curve, at this point, see this is what point A, this is what point B. Point B. At point A, what is the tangent drawn here? This is the tangent drawn at point A, right? This is the tangent drawn at point A. Now, which makes an angle theta 1 with x-axis. Of course, we can take here also by drawing a parallel axis with the x-axis. That is, if I take one axis parallel to x-axis somewhere here also, parallel to x-axis. So this is also theta 1 now. Why? Because these two are parallel to each other, right? In fact, what is the original curve here? This is the original curve, given curve. This is the original curve, given curve. Now, at point B, I am taking one more tangent. One more tangent is to be drawn at point B. Suppose I am extending here. I am extending x-axis like that, right? If I take one tangent at point B, see this is the tangent. If I extend, otherwise, if I take one axis parallel to x-axis here, see this is parallel to x. So here itself we can take theta 2, right? Angle made by the tangent drawn at point B, parallel to x or with x. With x means extend this one. Extend this one like that. So it cuts somewhere here, x-axis. If I take in anti-clockwise sense, that is to be taken with positive x-axis only, theta 2. If it is theta 2, this one also theta 2. See, this is what extended tangent drawn at point B. So here it is theta 2, here also theta 2, right? Now, here, what about the values? Somewhere here at point A, this is x1. At point B, this is x2. If you go from A to B, what happens? X increases. X increases. At the same time, what about tangents? Angle made by tangents. At point A, shoots up. At point B, shoots down. See, it shoots up. Tangent drawn at point A shoots up. Tangent drawn at B shoots down. See, from this position to this position. So theta 2 is less than theta 1. Theta 2 is less than theta 1. Of course, here both angles, otherwise angles at any point on the curve, obtuse or acute here, acute only, less than 90 means theta again positive, tan theta again positive, theta. Here, what about theta? Acute. Theta acute means tan theta. That is slope. What about slope? Is positive. Of course, theta acute at point A and point B. Therefore, tan theta, that is slope, positive. But what about values here? At point A, slope is somewhat more. At point B, slope is somewhat less. So here, what is the inference? What is the inference? That is tan theta. Tan theta, that is theta less than 90. For theta less than 90, tan theta, slope is positive. Again, positive. Slope is positive. As x increases from A to B, if you go from A to B, x increases from x1 to x2. So as x increases from A to B implies what happens? Theta decreases or increases? At point A, theta 1 is greater. At point B, theta 2 is smaller. Why? Because slope shoots down here. Initially, this is the slope. At point B, later on what happens? Slope decreases. So as x increases, theta decreases. Theta decreases. That is, as x increases, theta decreases means what about tan theta? Decreases. Tan theta decreases means tan theta means slope. So implies slope, that is equal to dy by dx decreases. Dy by dx decreases. Right? Right? But positive slope. Here. In this case, positive slope. Why? Because at any point on the curve, theta acute only. Therefore, slope is positive. Positive slope. Now coming to calculating slope at maxima and minima. Next examples. At maxima and minima. Third example. Right? What is the third example here? Number 3. Slope at maxima. Slope at maxima. See, in this example, point x, here it is point y. Right? See, this is the variation of y with respect to x as an example. Right? This is the variation of y with respect to x. I am taking 3 more points on the curve at point A, at point B, at point C. Right? At point A, at point B, at point C. Now, I am drawing tangents at point A, at point B, at point C to the curve. Suppose at point A, this is what tangent drawn at point A to the curve. Right? So this is what theta 1. Angle made by the tangent with the positive x-axis. What is that angle? Theta 1. Similarly, at point B, if I take one tangent drawn to the curve at point B, that becomes parallel to x-axis. Similarly, if I take one tangent drawn to the curve at point C on the right side, that is somewhere here, this is what tangent drawn to the curve at point C on the right side. So it cuts x-axis somewhere here. So this is what theta 3. Of course, we can take here also. This is what theta 3. So this point is C, theta 3. Right? So this is what point A. You can take somewhere here also angle by drawing an axis parallel to x-axis. So here also theta 1. These two same angles, right? Okay. Now, at point A, what about theta? Acute or obtuse? Acute. At A, theta 1, acute. Theta 1 acute means tan theta 1. That is slope. That is dy by dx. So for angle less than 90, that is for acute angle, what about tan theta? Positive. Is positive. Am I right? So at A, theta is acute, tan theta 1. Theta 1 is acute, tan theta 1 equals slope, that is dy by dx, which is positive. Why? Because theta is less than 90. Therefore, tan of less than 90 degrees equal to positive. Right? At point B, see at point B, if I draw one tangent to the curve, that becomes parallel to x-axis. Right? What is the angle made by this tangent with the x-axis means as these two are parallel to each other, theta is 90 degrees. So here theta 2, theta 2 is 0 degrees. A tangent drawn to B is parallel to x-axis. Therefore, what is the angle made by this tangent with x means that is theta 2 is 0. It's not 90, 0 degrees. So theta 2 is 0 degrees. Right? Neither acute nor obtuse. Therefore, theta 0 degrees. Now, what about tan theta? Tan of theta 2, that is slope equal to dy by dx equal to tan 0, 0. Therefore, 0. See here, slope can be positive. Slope can be 0. Right? Slope can be 0 also at maximum. So this is what at D means at maxima. At maxima. So at maxima, what is the slope of curve means 0. So slope at maxima. What is the inference is slope at maxima equal to 0. What is maxima means among all possible values at this position y becomes maximum. See here y max. This is what y max. At point B y becomes maximum. So at the same position, what about slope here? Slope at maxima equal to 0. Right? And here if you observe, see here at point A, slope is positive. At point B, slope is 0. Now at point C, we left with point C. What about slope at point C? Once tangent is drawn at point C, which makes an obtuse angle with positive x-axis. See, at point C, if I draw one tangent to the curve, right, that makes an angle more than 90 degrees. Means at point C, theta 3 is obtuse. Means greater than 90 degrees. Greater than 90. Tan of angle greater than 90 degrees becomes negative. So tan theta 3 equal to slope that equal to dy by dx is negative. Am I right? See, tan of more than 90 degrees negative. So beyond B at any point on the curve, beyond B at any point on the curve, theta is obtuse, greater than 90. Therefore, slope is negative. Right? At any point from A up to just before B, theta is obtuse. So what about slope from A to just before B means positive. At exactly B, theta, that is slope angle is 0. Therefore, tan theta slope also 0. Right? Now, what is inference here? From A to B, from A to just before B, slope is positive. Exactly at B, slope is 0. But beyond B, slope is negative. So slope equal to, how it changes? Positive to 0, 0 to negative. So positive to 0, slope becomes positive to 0, 0 to negative. See, any quantity changes in such way that positive to 0 and again from 0 to negative. What about the quantity means? Decreases or increases? Decreases. See here, positive to 0. Point approaches from positive to 0, 0 to negative. Means plus 2, plus 1, 0, minus 1, minus 2 like that. Means quantity decreasing. So slope, right, that is, what is the inference here? D by dx of dy by dx. dy dx of dy by dx. See, dy by dx means slope, but here d by dx of dy by dx means the rate of change of slope with respect to x. Right? As x changes, slope changes here. Slope is not constant. Why? Because it's not straight line. So slope changes in such a way that from positive to 0, 0 to negative. So d by dx of dy by dx means d square y by dx square. Alright. What happens? Decreases. Increases or decreases? Decreases. Right? So from A to B, just before B, positive, slope is positive. From B to B at B, slope is 0. Beyond B, slope is negative. So slope changes from positive to 0, 0 to negative means there must be rate of change of slope with respect to x. That is what d by dx of dy by dx. That is d square y by dx square. So changes from positive to 0, 0 to negative means what happens? Decreases. Right? So this is what rate of change of slope. This is to be pronounced as rate of change of slope. Right? Coming to maxima. After maximum, what is the point here means? That is slope at minima. Slope at minima. Slope at minima. See, let us see. Slope at minima. Now let us see. Slope at minima. See, this is what point y, this is what point x. Suppose there is variation of y with respect to x as shown. See, this is the variation of y with respect to x. Right? Concave upwards. Previous convex upwards, here concave upwards. Right? See, among all possible values at this x, what about y? It becomes minimum. So this is the lowest value. Means y minimum here. Y minimum. So similarly, as in the previous, I am taking 3 points on the curve. One is at point A, another one is at point B at its lowest value of y. One more here at point C. Am I right? So A, B, C. Okay. Now I am drawing tangents to the curve at point A. One is at point A like that. Right? One more is at point B like that. At point B like that. One more is at point C like that. At point C like that. Am I right? Okay. Now what are the values here? Angle made by the tangent drawn at point A is theta 1. Of course, here also you can take theta 1. This is what A. It is theta 1. At point B, what is the angle made by the tangent drawn at point B? 0. Why? Because this is what tangent which is parallel to x-axis. Now what is the angle between tangent and x-axis means 0. So 0. It is theta 2 is 0. Now what about tangent drawn at point C? That is making one angle theta 3 with positive x. Otherwise same can be taken somewhere here also by taking one parallel axis with x. That is what theta 3 also. So theta 3, theta 1. Here it is theta. So coming to this value, what about this value? Minimum value of y. That is what? Minimum. Right? At point A. This is what? Point A. At point A, theta 1. It is obtuse or acute here. See? This is what? More than 9 degrees. So theta 1. Obtuse angle. So tan theta 1, that is slope equal dy by dx. What about the tan of obtuse angle? Negative, right? At point B, at maximum or minimum? Minimum. It is not maximum, minimum. So this is what? Among all possible values of y, at point B, it takes minimum value. So this is what? Lowest value or minimum value. at point B, otherwise at minima, theta 2 is 0. Therefore, tan theta 2, that is slope, that is dy by dx is 0. Slope at minima also, not at maximum. Of course, not only at maximum, at minima also. At minima also, slope is 0, right? Coming to point C. Point C, see at point C, what about theta 3, that is less than 90? Acute angle less than 90, acute angle. So theta 3 acute, that is less than 90 degrees. Tan of theta 3, that is tan of less than 90 degrees is positive, right? Slope changes like this. See, initially from A to just before B, what about slope? Negative from A, otherwise from starting point here. Otherwise from A, what about theta and tan theta? Means negative. From A to there, just before B also negative. Exactly from at B, 0. Beyond B, positive. So slope changes from A to C via B like this. See, slope changes from negative value to 0, 0 to positive, right? So negative to 0, 0 to positive. So any value changes in such a way that -2 to -1, -1 to 0, 0 to +1, +1 to +2 means value said to be increasing. So here slope increasing. So d by dx of dy by dx is d square by dx square is increasing, right? So rate of change of slope increasing. Okay, rate of change of slope increasing. Okay, friends. So that's about in this lecture. We will discuss the variation of x, means the variation of position with respect to time, the variation of velocity with respect to time, the variation of acceleration with respect to time in detail in the next video. Thank you.